Hello everyone, myself Muhammed Shahid C K. Today I am going to talk about oxygenators. Coming to the specific learning objectives, at the end of the sections, the learners will be able to know about history of oxygenator, types of oxygenator, gas transfer in oxygenator, bubble oxygenator and membrane oxygenator. So what is oxygenator? Oxygenator is a mechanical device that oxygenates the venous blood by removing excess carbon dioxide and increases the partial pressure of oxygen. That is, oxygenator is a device which oxygenates the venous blood. They are a complex device made up of distinct components such as membrane modules, heat exchanger and reservoir. Nowadays, these oxygenators are an integrated component. They are capable of performing many functions of the native lungs. Coming to the history, in early 1915s, attempts were made to oxygenate the blood using techniques such as cross circulation. On May 13, 1955, Dewar and Lillehay first used their helix reservoir bubble oxygenator in a human. It was the first successful oxygenator which was used in human cardiac surgeries. In 1956, rotating disc oxygenator was developed, and in 1966, Dewar introduced the hard shell bubble oxygenator with integrated heat exchanger. So this diagram shows a pictorial representation of development of oxygenator. So there are two types of oxygenator actually, artificial oxygenator and natural oxygenator. So under natural oxygenator, we can characterize them as homologous oxygenators and heterologous oxygenators. Homologous oxygenator means we are oxygenating the venous blood from within the same species or within a human or other human's body. That is, it is demonstrated by example of controlled cross circulation. Under heterologous oxygenator, we can use either other organisms' lungs to oxygenate the bloods of humans. Then under artificial oxygenator, we can characterize them as bubble oxygenator, film oxygenator and membrane oxygenator. Then what are the ideal characteristics of an oxygenator? It should have excellent gas exchange, it should cause minimal blood trauma, it should have small priming volume, easily assembled and safety, minimal failure incidents. In case of any failure, we should be able to replace the oxygenator very quickly without any complications. So oxygenators can be mainly classified into two types, bubble oxygenator and membrane oxygenator. Bubble oxygenator. In bubble oxygenator, the gas bubbles are dispersed into the venous blood in bubble column. It has a direct blood gas interface. So in bubble oxygenator, what we are actually doing is we are pumping the gas bubble into the blood. Gas bubbles are dispersed into the venous blood in the bubble column and act as a vehicle for gas transfer for both oxygen and carbon dioxide. Oxygen diffuses from the bubble into the blood film surrounding the bubble. The exchange of gas mainly happens based on the principle of diffusion. The rate of diffusion is proportional to the partial pressure gradient of the gas. So we know that this oxygenation happens based on diffusion. So diffusion is movement of particle from higher concentration to lower concentration. The main advantages of bubble oxygenator is the low resistance to the flow and low pressure drop across the oxygenator compared to membrane oxygenator. The main disadvantages of bubble oxygenator is it has direct contact between blood and air that permits the formation of gas emboli. So in bubble oxygenator, there is a direct contact between blood and gas. This may result to the formation of gas emboli, and this gas emboli, when entered into the patient's circulation, it's very harmful for the patient. Bubble oxygenator includes three primary sections of operation: bubble column, debubbling area or defoaming area, and arterial reservoir. Bubble column consists of the mixing chamber where oxygen is dispersed into the venous blood. CO2 removal is dependent on the volume of oxygen. Also, the CO2 removal is dependent on the size of the gas bubbles. That is, smaller bubbles oxygenates the blood faster and larger bubble eliminates the carbon dioxide faster. The second area is defoaming area. After oxygen, the mixture of blood and gas which emerges from the oxygenating column must be deformed. So to deform the blood, an open sponge with antiform A is placed in the path of the oxygenated blood, and this oxygenated blood after deformation goes to the arterial reservoir. Arterial reservoir is used to store the arterial blood. There must be a smooth blood flow through the reservoir. So bubble column can be arranged in two designs mainly, sequential design and concentric design. In concentric design, the bubble column is surrounded by deforming area and the arterial reservoir as depicted in the diagram. Bubble column is surrounded by debubbling area and then surrounded by arterial reservoir. In sequential design, bubble column is in separate series with other two sections. That is, first there will be bubble column, then deforming area, and then arterial reservoir. So what are the advantages of bubble oxygenator? The main advantages is that it was efficient, it was inexpensive, heat sterilizable, easy to assemble and check, had no moving parts, and easily disposable. The disadvantages of bubble oxygenator is that it has higher risk of air embolism, it causes complement activation, it requires larger priming volume, and it also causes post-operative trauma. So coming to the next one, membrane oxygenator. A membrane oxygenator consists of a thin gas permeable membrane separating the blood and gas flow in the CPB circuit. Oxygen diffuses from the gas side to the blood and carbon dioxide diffuses from the blood side into the gas for disposal. In membrane oxygenator, the blood and the gas side will be separated by a semi-permeable membrane. So based on the principle of diffusion, the exchange of gas happens in membrane oxygenator. The main advantage of membrane oxygenator over bubble oxygenator is that it avoids direct contact between the blood and air, which prevents the formation of bubbles. They are organized into three configurations based on the arrangement of the fibers. That first one is scrolled envelope, second one is parallel plate, and third one is hollow fibers. So these membrane oxygenator have two main parts. First one is cardiotomy reservoir and second one is the membrane. So this cardiotomy reservoir is the part where the whole blood is stored. It can be classified into mainly two types, hard shell reservoir and soft shell reservoir. Hard shell reservoir, it is exposed to the room air, so there is a chance of entry of air into the circuit. This soft shell is made up of soft collapsible bag. So in case of any failure, the bag will collapse and it will not enter air to enter into the circuit. The next part is membrane. The most commonly used membrane is microporous polypropylene membrane and true membrane. So coming to microporous polypropylene membrane. The microporous polypropylene hollow fiber is the most common membrane oxygenator used. The gas exchange in the membrane occurs by diffusion through the membrane wall and transit via the microporous channel. In earlier days, the design of the membrane oxygenator was the flow of blood was through hollow fiber and gas surrounded hollow fibers. The most advanced design shows flow of gas through the hollow fiber and blood around them. The most of the designs today rely on the flow of gas through the hollow fibers with blood around them, as I mentioned earlier. So this configuration reduces blood pressure drop across the oxygenator. So this shows the modern blood flow in a oxygenator, membrane oxygenator. So as you can see, we can see blood inlet, blood outlet, hollow fibers, and gas inlet and gas outlet, and water inlet and water outlet. When microporous membrane oxygenator is used, it is extremely important that the pressure in the blood side must always exceed the pressure in the gas side. It's mainly done to prevent the possible entering of air emboli from gas side to the blood side via microchannels. The surface tension of blood prevents plasma water from entering the gas side of the membrane during CPB and prevents gas leak into the blood side. After several hours of use of microporous membrane, the plasma leaks into the microporous, resulting to limited gas exchange. So when we are using this microporous membrane, there is a chance that air may leak from gas side to the blood side. So as a result, the oxygenation won't be happening properly. after a certain time, that is when this membrane oxygenator is used for more than 6 hours, the perfusionist must increase the observation of gas exchange by increased blood gas sample, continuous check of difference of the color between arterial and venous line, and must be ready to replace oxygenator if needed. The membrane oxygenators have high resistance to the blood flow across the membrane. So as a result, we must pump the blood throughout the membrane oxygenator. So while pumping, we should note that the pressure should not exceed that of the membrane. So if the pressure is high, there is a chance that the membrane oxygenator's membrane may rupture. Excessive pressure through the membrane can cause rupture, resulting a blood leak or air embolism depending on the flow conditions. So moving to the next one, true membrane. True membrane oxygenator are manufactured by coiling silicon rubber sheets in a cylindrical fashion. Silicon is a thermoset plastic. It has better dimensional stability, heat resistance and chemical resistance. These true membrane oxygenators are mainly used for surgeries which is done more than 6 hours. So in true membrane oxygenator, there is no leakage of air into the blood side. Blood is kept on one side of the membrane and gas on the other side. The membrane provides a complete partition between the blood and gas so that the transfer depends totally on diffusion of gas through the membrane material. These oxygenators have a larger surface area than hollow fiber oxygenator and demand larger priming volume and is more expensive. The true membrane is used in long-term support such as ECMO because of its ability to maintain stable gas transfer for a long period of time. The main principle by which both the oxygenator work is diffusion. So what is diffusion? Diffusion is movement of particle from higher concentration to lower concentration. The rate of diffusion is proportional to the partial pressure gradient of the gas. Diffusion of gases in the membrane oxygenator mainly depend on these characters, that is partial pressure gradient of particular gas in the blood and gas phase, diffusive characteristics of a gas, concentration of gas, physical characteristics of the membrane like its material, surface area, etc. So how the blood flows inside an oxygenator? So as we know that the modern oxygenator is an integrated equipment. So it is integrated of heat exchanger and oxygenator. So blood mainly passes through two circuits or two compartments. That is, first one is heat exchanger and then the second one is gas bundles. The blood first flows through heat exchanger and then through the gas bundles. Gas bundle is the core of the membrane oxygenator. It is made up of polypropylene or silicon sheets. So here are the basic differences between a bubble oxygenator and membrane oxygenator. Under bubble oxygenator, mostly the structure will be helical, blood and gas mixed in single chamber, large priming volume, high risk of emboli, fixed flow are given, heat exchange by generation of bubbles and dependent on surface area of the bubble. And in membrane oxygenator, fibers formed in compartment, blood and gas in separate chambers, smaller static priming volume, no chance of air embolism, flow can be altered, gas exchange by diffusion. So after this section, we came to know about what is oxygenator. Oxygenator is a device which is used to oxygenate the venous blood during CPB. There are some basic ideal characteristics of oxygenator which include it should be easily available, low priming area, no damage to the blood component and easily replaceable in case of any failure events. Then we came to know about what is bubble oxygenator, what is membrane oxygenator. In bubble oxygenator, there is a direct contact between air and blood. So as a result, there may be chance of air embolism. And in membrane oxygenator, the blood and the gas will be separated by a semi-permeable membrane. And the principle of oxygenator, that is diffusion. Both the oxygenator work on the common principle, that is diffusion. Thank you.